The brain remains one of the most profound mysteries in science. As neuroscientists explore its depths, they are uncovering remarkable insights about what drives our thoughts, emotions, and actions. According to experts like Susana Martinez-Conde, Talia Wheatley, and Yuri Maus, the brain is responsible for everything that makes us who we are, yet a significant portion of its workings occurs outside of our conscious awareness. This raises intriguing questions. What part of the brain is truly in charge, and how much control do we have over our actions? Heather Berlin, a neuroscientist and clinical psychologist, embarks on a journey to uncover the hidden processes within the unconscious mind. While we might feel like we're in control, Berlin suggests that our brains often have their own agenda. With nearly 90 billion neurons working together, the brain creates the illusion that a singular self resides in our skull. In reality, much of what we do happens without our conscious input. Anil Seth emphasizes that the perception of control is central to our identity, yet our brains may contradict this belief. There are instances where the brain's coordination slips, revealing how different parts of the brain work both in unison and independently. For example, in cases of sleepwalking, people perform complex tasks like walking or even driving without conscious awareness. Neuroscientists such as Emmanuel During study how such behaviors are possible by examining brain waves and bodily movements during sleep. The brain's remarkable ability to operate without conscious input extends beyond sleepwalking. Neuroscientists have discovered that certain brain regions can function independently of others. For instance, the prefrontal cortex, responsible for decision-making and self-awareness, might be disengaged while other areas of the brain remain active. This phenomenon is particularly evident in sleep disorders, where individuals unknowingly perform actions during deep sleep. Berlin visits a sleep center to observe how brain waves change during different phases of sleep. In deep sleep, brain activity slows down, but in sleepwalkers, certain regions of the brain, such as the motor cortex, remain active, allowing for movement. This raises the question of what truly governs our actions during unconscious states. Consciousness itself is a layered concept. Seth explains that it comes in degrees, ranging from everyday awareness to deep sleep or anesthesia, where consciousness fades completely. Berlin reflects on her experiences as a young researcher in anesthesiology, observing how brain activity changes under anesthesia. Using an electroencephalogram, EEG, scientists like Emery Brown monitor brain waves to determine when a patient loses consciousness. The thalamus, a small region deep within the brain, acts as a communication hub, coordinating signals across different brain areas. However, despite advances in neuroscience, we still do not fully understand how neurons work together to create consciousness. The brain's complexity is such that even when its basic functions are understood, the emergent property of consciousness remains elusive. Scientists like Rebecca Sachs point out that while we know anesthesia alters consciousness, we are far from comprehending how these changes result in the loss of self-awareness. As research progresses, one thing becomes clear. The brain is constantly adapting and changing in response to both internal and external stimuli.